Question number 5 deals with photoelectric effect experiments. Experiments were carried out by, yes, name of the person, yes, yes, first one was Henrich, the second one, sorry, Hallwatch and Leonard, 1886 to 1902. What were the experiments? First of all, what was the apparatus? Again, evacuated tube, metal plate, some voltage, and there is a bulb, voltage applied to the bulb. Voltage given to the bulb is written as V2 or V1? V2. Voltage available here is termed as V1. Photons, light from the bulb is incident on the metal surface. And you measure this current, ammeter or microammeter. What was the experiment? Experiment number 1 was, which of the two voltage is constant, V1 or V2? V1 is constant. Say 1 volt. Means you want to change this value. During experiment number 1, we will keep V1 as constant. V2 is variable. Means using a regulator or a rheostat, you can change voltage across the bulb. If you change voltage across the bulb, power, yes. If you change voltage across the bulb, power changes. So, if you vary this voltage V2, power changes. If a power of the bulb is 5 watt, certain amount of energy comes, light energy. If you make it 10 watt, more energy, 15 watt, 20 watt. If you increase this voltage, wattage of the bulb increases. We have to plot a graph. Graph of what? Along x-axis, yes. Intensity of light. And current in say microammeter, microamperes as measured by micrometer. 2 minutes with you to draw the diagram. 2 minutes to draw the diagram. V2 variable, say 0 to 10 volt. If it is so, then emitter reading, that is also variable. These parameters will vary. Experiment. Step 1. If I make this voltage 0, there is no voltage across the bulb. Current flowing in the bulb is 0, light coming out of the bulb is 0. If the light coming out of the bulb was 0, this reading was also 0. That means if intensity is 0, current is also 0. Now you increase this voltage V2. Say make power 5 watt. And we measure this current. When we measure this current, this comes out to be say 5 units, 5 microamperes. That means if intensity is 5 units, current is also 5 units. Then we increase this voltage such that the wattage increases. Suppose now it is 10 watt. Then the current is also 10 units. If it is 10, this is also 10. 5, 5, if it is 10, it is 10. If it is 15, this is 10. If it is 15, this is also 15. So what was the observation? Observation as intensity increases, current also increases. And what is the relationship? Straight line. The graph is a straight line. What was the explanation? Explanation was after 1905 by Einstein's equation, to be covered in question number 6. Explanation by Einstein was, when you increase, when it is 0, there is no photon coming. If there is no photon coming, electron ejected is 0. So there is no current. When it is 5 watts, suppose 5 photons are coming. Einstein's theory is 1:1 interaction. One photon interacts with the one electron. So if we say one photon ejects one electron, then 5 photons will eject how many electrons? 5 electrons. So when 5 watt means 5 photons say and 5 electrons. So current is also 5. When it is a 10 watt, say number of photon is 10, now the number of electrons is also 10. That is why explanation was 1 as intensity increases, number of photons increase. So number of electrons, photoelectrons also increase. So current also increases. This is the explanation. Time with you is 3 minutes to write. 3 minutes to write. Experiment number 2 deals with what? Experiment 2 is, yes, V2 is, yes, V2 is constant. For a particular graph, we'll keep this voltage V2 constant. What about V1? V1 is variable. We can keep this as positive, we can keep this as negative also. That means you can have this one also. It can be positive or it can be negative also. So V1 is what? V1 is variable. It can be positive, it can be negative. V2 is constant for one particular graph. After that, we'll change after some time. Emitter, yes, variable. You have to plot a graph of what? Along y-axis, yes, current, same, no variation. How this current varies? When you vary this voltage, that means what? V1. If there is no voltage, so this value is fixed. Say power is fixed. Say 5 watt. In the graph it is given as first is 25 or 5? 25. We can give it 25, not an issue. so that it is same as the nodes. So at present it's a 25 watt bulb, certain photons are coming, some light is coming, and there is a current. This value, when there is no voltage, when V1 is 0, that means it is connected by a wire only. Still you observe some value of current. If you make it plus 1 volt, yes, what is the effect? If you make this plate positive with respect to this, the observation was the current increases. If you make it plus 1, current increases, plus 2, current further increases. And the observation was, this is how the graph is. When you make it negative, means what? Minus 1, then the current decreases. Minus 2, current further decreases. Minus 3, reduces to 0. So the observation was minus 1, this is minus 1, minus 2, minus 3. At minus 3 volt, the current reduces to 0. This was the observation. Repeat. Observation was, as voltage is positive, current will increase. If V1 increases, current increases and gets saturated 100%. If V1 is negative, minus 1, minus 2, minus 3, the current decreases. Current decreases. And when V1 is, say, minus 3 volt, in this particular case, current reduces to what? Current reduces to 0. What was the explanation given? Explanation given by Einstein was that when this is fixed, bulb is fixed, you are getting a photon of, say, 5 electron volt unit. If 5 electron volt photon is coming, it hits the surface, and suppose the work function of the metal surface is 2 electron volt. How much? 2 electron volt. So this photon of 5 units hits the surface, work function is 2 electron volt. So the electron is ejected from the surface, and that electron will have what maximum possible energy? 3 electron volt. When you make this plate positive, you are attracting the electron. That is why the current increases. So when V1 is positive, electrons are accelerated. That is why the current increases. When you make it negative, minus 1, minus 1, minus 2, minus 3, then these electrons, emitted electrons are, yes, retarded. This negative plate will oppose this electron. So when it is minus 1, number of electrons reaching the surface will be less. When it is minus 2, the number of electrons will further decrease. When minus 3, this one, no electron reaches the surface. When V1 is equal to, say, minus 3 volt, no electron reaches. So current is 0. And what do you call this as? Yes. What do you call this as? Stopping potential. The voltage required to make current equal to 0. Time with you is 3 minutes to write. Experiment number 3 deals with what? Experiment number 3 deals with effect of a frequency. Previous experiment was experiment number 2. This is experiment number 3. Experiment number 3 is what? Effect of, yes, frequency. Frequency of photons, that is this light. Quality of light, you can say. So, we perform one experiment with, say, one bulb. What is constant, what is variable? Yes, you have to plot a graph. Graph of, yes, graph of current as a function of voltage. Which voltage? V1 or V2? Yes. Yes, this voltage is V1. You have to plot a graph of current as a function of voltage, same as in the previous question. What is the change? We will change number of bulbs. We will perform experiment with number of bulbs. Effect of frequency V1 is variable, and this V1, no, there is a correction required. V1 is a variable. V1 is a variable. We'll first perform this experiment with one bulb. When you say change, effect of change of frequency, frequency changes. We will perform this with, say, a red color, then with the blue color. A red color packet is a small packet, high wavelength, low frequency. Blue color packet is a low wavelength and a high frequency. So, we first perform this with the red bulb. If you perform this experiment with the red bulb, the number packet is, say, 4 units. Each packet, first let me write the observation, not the value. What was the experiment? When you perform it with the red bulb, the observation was same graph as you plotted in the previous one. So that means what? If it is 0, if V1 is positive, the current increases, and if it is negative, this value becomes 0 at certain point, say -2. This is the experiment with the red bulb. Now you change the bulb. If you change the bulb, and now you perform the experiment with the blue color. When you perform it with the blue color, size of the packet, yes, size of the packet increases. And the observation was, when you perform this with blue color, the graph pattern is same, but this value, the current is 0 at, say, -3 volt. This was the observation. Means what? Observation was with low frequency, in this case a red color bulb, stopping potential was small. Say, how much? -2 volt. With the high frequency, in this case, say blue color, stopping potential was high, say -3 volt. This was the observation. What was the explanation? Yes, explanation was in 1905 by Einstein. If it is red color, say it is 4 electron volt packet, and work function of this metal is say 2 electron volt. So when this packet of 4 electron volt will hit the surface, 2 electron volt is used to eject the electron. Topper, that is electron with maximum kinetic energy, will come out with what? Will come out with 2 electron volt. So you need to have this value as -2 to stop it. 1 electron volt is what? Amount of energy, yes, possessed by an electron when it is accelerated through 1 volt. Or it is 2 electron volt means how much voltage is required? -2 volt to stop it. So this value was -2. Einstein said when you change this to high energy, suppose it is now 5 electron volt. When this 5 electron volt hits, work function remains same. How much? 2. And now the topper will come with what energy? 3 electron volt. Electron comes out with what energy? 3 electron volts. This plate should have what voltage? -3 to stop this, to make the current 0. So that is why current is 0 when this voltage is -3. Stopping potential is more when photon size increases. Again it is 1:1 interaction. So this graph was also explained by Einstein using his equation to be covered in question number 6. So what is the explanation? As photon size increases, stopping potential increases. How? Because it is governed by this equation. H nu is equal to work function plus kinetic energy maximum, which is what? H nu is equal to work function plus E into V stopping. He said when this value in the first case is how much? 4 units. Work function, sorry, first case is red color, I will change it. First is 4 units, this is 4 units. Work function is 2 units. What is the stopping potential? 2 units. So 4 is equal to 2 plus 2. When you change it, now it is blue color. This energy is how much? 5 is equal to work function 2. Stopping potential is 3. So the explanation is given as per this equation to be discussed in question number 6. Time with you is 3 minutes to write.